Alright everyone, so let's go through this notes packet and see how we do. So first off, congruent. Two polygons have the same angle measures and same side lengths. We would call that congruent. So are all of these angles and sides congruent? So we have a 90-degree angle in each, and then we have a 28-degree angle in each side. So if we were to do the triangle angle sum theorem, which says we subtract each of these numbers from 180, we would end up with 62 degrees. So 62 degrees would be our missing angle. And for both of them, they have the same angle. Alright, sorry for the background noise. I might have to go wake up baby soon. Alright, so then we have to do the missing side length. So 16 and 30. We have 16 and 30. So we got to find that missing side, and to find the missing side of a triangle, we have to do a squared plus b squared equals c squared. So we got 16 squared plus 30 squared equals c squared. That's 256 plus 900 equals c squared. So 1,156 equals c squared. So then we will square root both sides. Square root, and we get c equals 34. Okay, so each of these sides would be 34. Next says, what is a sequence of rigid transformations that maps the triangle on the left to the triangle on the right? So this would be a rotation. Then a translation. We would have to rotate the shape, and then we would have to slide it over for it to go on top of itself. So to write a congruent statement, we got to make sure that the angles line up. So if I were to do TRI, triangle TRI, the order and how I name these matters. So T was angle 62. So I got to make sure I go with the angle that was 62 in the other triangle, which was G. So that'll be triangle G. So T and G line up now. My next letter has to match up with R. R was the 90-degree angle. So then I have to do the 90-degree angle in the other triangle, which was A. So that's triangle GA. And then N would be the last letter. Okay, you gotta make sure that the letters line up in the same order when you do a congruent statement. Okay. 1 second. Okay, so next up we have some reminders, and these are in front of you guys. So side, side, side. Side, side, side is where all three sides are congruent. Well, there's three pairs of congruent sides. Okay, so these two are congruent, the hypotenuse was congruent, and the other side was congruent. Okay. These ones are a little bit more nuanced. So, give me a second. So when we do this, SAS, okay, it's called SAS because you have a side, oops, you have a side an included angle, and a side. The important thing is the angle has to be made up of the two sides that are marked congruent. So, for example, if I had this triangle, and this was called triangle XYZ, the two sides that are marked congruent are side length XY and side length YZ. So which letter do they share in common? Y. And you can see that Y is the angle that's marked. So we know Y is the included side. The letter that shows up twice is the included angle. And you need that one to be marked for it to be SAS. Sometimes what will happen is you'll see a triangle that'll look like this. And then they'll do something like this. This is an example of a triangle that is not side angle side, because that angle is not the included angle. For example, if I were to call this triangle A, B, and C, the side lengths that are marked are side lengths AC and side length BC. So look at which letter is mentioned twice. It's angle C. See how C is not the one that's marked in the triangle? That's how you know this is not SAS. So next up, we have angle side angle. So similar to side angle side, except now the side is between the two marked angles. So another way you could check this, let's pretend this is triangle XYZ. The two angles that are marked are angle Y and angle Z. And which side length is marked? Side length YZ. So since the two angles that are marked make up the marked side, that's how you know it's an included side. And this is angle side angle. Conversely speaking, if we were to look at angle angle side, so let's call this triangle ABC. In this triangle, angle B is marked, angle C is marked, but the side that is marked is AB. So since these are not matching up, this would be AAS. The side is not between the two angles. And finally, we got hypotenuse leg. This only works if it's a 90-degree angle. If one of the legs is marked and the hypotenuse is marked in a 90-degree triangle, then you would say it would be hypotenuse leg. Sometimes they'll try to trick you. They'll give you a triangle that looks like this, and they'll give you these two sides. Okay. This would not be hypotenuse leg. This would instead be side angle side. So side angle side. Okay, because that's the included angle. So just be aware of that. That's something that might happen. Alright, so let's take a look at number 2. Number 2 in your notes packet says, redraw the triangles. So to redraw the other triangle, we'll draw it to look like this one. So V is the one that's between 6 and 12, and the letter that's between 6 and 12 is P, so P would have to go on top. That's the one between 6 and 12. And then on the other side of the 6 is an M. So on the other side of the 6, I'll put an M. And then I know N has to end up over here with side length of 15. So are the triangles congruent? This would be a yes. There are 3 pairs of congruent sides. And 3 pairs of congruent angles. So we got a couple more to look over. We need to say if they are congruent, yes or no. So for all the following, determine if the following pairs of triangles must be congruent, yes or no. So for this one right here, we have a side of 8, side of 11, and then the angle in between them, which is the included angle, is equal. So these ones are congruent. We'll say triangle ABC is congruent to triangle, and we have to make sure we go in the same order. So it has to go the side without the angle in 8 to 70 degrees to the other side. So the side without the angle in 8 would be F to 70 to the other side. So this has to be F, E, D. You have to name it FED. If you name it any other way, it is incorrect. The theorem that's used would be side, angle, side. And then the series of transformations that would be used would be a rotation, and then a translation. Next up for part B, these guys would actually be not congruent. At least we don't know they are. The reason being is you have 12 and 16, but this is not an included angle. Or it is the included angle, excuse me. See, you have LJ, side length WJ. J is the one that's repeated twice. But if you go on the other side and you look at the marked sides, you've got side length TP and side length VP. So V would need to be marked to be the included angle. It is not, so therefore these are not congruent. So for C, we have the arrows. What do the arrows mean? I wonder if you guys actually answer that. Parallel. So since they're parallel, these guys are actually alternate interior angles. And these guys would actually be vertical angles. So, and we actually have another pair of alternate interior angles on the other side. So it really depends here. You have 2 correct answers. Okay. Your congruency statement, you would match them up according to their arcs. So we have N to X to M. I did it in terms of arcs. So we have triangle N, X, M. We're going from single to double to triple, so that would be triangle YXZ. You could use either angle, angle, side, or angle side angle, depending on which sides or angles you marked congruent. And the sequence of transformations here would be rotate, or just a rotation. It really would just need to rotate. I believe it would rotate 180 degrees. So for these congruency statements, first off, we could prove that this is a 90-degree angle because this would be a linear pair. Another thing is this side AD, on the left side you have ACD, on the right side you have ABD. They both share this side in common. This is called the reflexive property. So these two are congruent. We would do triangle ADC is congruent to triangle ADB. And these two would be congruent by the hypotenuse leg theorem. Okay. We have a 90-degree angle. Our hypotenuse is ticked off. The other leg is ticked off for both triangles. And this would just be a reflection over line AD. I'm sorry, I probably tabbed over too quick, so I'll let it sit down for a little bit so you can copy down. Hopefully that turns off the buzzing for you guys. Alright, here we go. Okay, so then we got these guys. This one would actually be so this is the reflexive property. And then we have this angle would be congruent to this angle. So 1, 2, dash, 1, 2, dash. Even though it doesn't look like it, this is technically congruent. Okay, so I'm going to go from single to double. Triangle EHF is congruent to triangle GFH. This would be angle, angle, side. You could technically do angle, side, angle as well. So either one of those would work. However, this would not be a reflection because if you were to mark these angles up, the double angle and the triple angle would line up on top of each other, and you want the double to line up with the double arcs. So this one would actually have to be a rotation. And then for this last one over here, we know the sides are congruent by the reflexive property. However, since it's not an included side, we would have to say that these are not congruent triangles. Okay. If these arcs were over here, it would work. Side angle side. But that's not the case. So these triangles are not congruent for part F. Okay? So go ahead and work on your guys' homework packets. And you guys have 211, which will be due on Monday. Have a great weekend. See ya.